working or not? But I have a loud enough voice, I don't need this anyways. I've never been accused of being quiet, ever. Okay, we have another presentation. Yeah, that's where we're at. Where are we at here?
Keynote.
Dr. Jacoby,
Yes.
the keynote address.
Thank you. So what I'm going to walk through today is something I gave at the RO Symposium, and I was asked to come here and give it another go. So basically trying to look at what has happened in the lagoon recently and go back a little bit and hindcast what might have gone on that kind of got us where we are, and then see what that tells us about where we're going in the future. So the focus is going to be on this northern part of the system, so you won't hear about Lake Okeechobee discharges from me. No, that's a major issue, but we got our own set of issues. It's one of the things about the length of the lagoon. The basis for what I'm going to talk about is an investigation that was funded by the St. Johns River Water Management District back when the super bloom, as we called it at that time, happened, and people became concerned, rightfully so. I mean, that was just as the Basin Management Action Plan process was really starting to bite, and people looked at the lagoon and said, well, you know, what can we do about this? Look what's happened, even though we're trying. So what this basically means is I steal information from all of these people and bring it to you folk. So let's take a look at the recent conditions, and what we're going to start with is chlorophyll. And chlorophyll, as you might remember, is our measure of phytoplankton, as it were. It tells us how much phytoplankton's in the water column. And we're going to, a bunch of these graphs will be the same. Mosquito Lagoon, Banana River Lagoon, and Northern Indian River Lagoon are all different colored lines. And basically it's just a time series. So we take monthly samples. It's just showing you how the monthly samples have varied. So if you look in the past, you can see that every now and then we got sort of 40, maybe 50 micrograms of chlorophyll per liter. But then we came over here, and this one on the far right, that's the super bloom. So nearly double what we'd recorded in the past. And that was true pretty much throughout that whole northern section of the lagoon. Plus, if you look at this little bracket here, it lasts longer, right? So it was about double or more the usual duration of the bloom. So that's why it was dubbed the super bloom, because it was more intense, there was far more chlorophyll, and it lasted longer. This yellow arrow here is what we call Laurie Morris's bloom, and she thinks that that's one of the precursors that kind of led up to this whole deal. The reason we worry about chlorophyll is because it attenuates light. So the phytoplankton in the water column absorb the light before it gets to the bottom, which is where the seagrasses live, which is what the system, that's the target for the system, to have seagrasses. They do a lot of really good things. Won't go into all that right now. So this is percent incident. PAR is just the photosynthetically active radiation. It's the part of the spectrum that the plants actually can use. And that's at 1 meter, because you have to know how deep you are to look at the attenuation. So again, you can see that those chlorophyll levels, when they went up, you get dips in this PAR. And if you get below 20%, that'll start to stress things like seagrasses. So the superbloom definitely caused some stress. And you saw that in the seagrasses. And seagrass is a metric that's used in all the basin management action plans for this northern part of the lagoon system as the metric that we will use to tell us that we've restored the system. So it came out of the total maximum daily load process, and it will be our way of saying, yes, we're on track, or no, we haven't gotten there yet. So here we have two different measures of how much seagrass is out there. One is from mapping, which we do about every other year now, and that's in acres, and that's the green bars match up with that left-hand axis. And the other thing that we do twice a year now is we go out and do transects, where they run a line perpendicular to shoreline, look at a variety of things, including how far out the seagrass extends. And so what we get is a very good correlation between acres and transect length. And so it can show you what happens in between maps, as it were. And that's this orange line, mean transect length in meters. So you can see that both of them dipped after that and during that 2011 bloom. So it actually went down to 60% of what we had in 2009. So 2007 was our peak. There's even more seagrass out there than the 1943 maps. So people had expected, and we found out that yes, even in 1943, you're already seeing effects of population, as it were. All right. So since then, what's happened? So again, we go back to chlorophyll. So now this red arrow shows you the super bloom, as we called it. Well, you can see that we've had bigger blooms, and in fact, this bloom, particularly in Banana River Lagoon, which is that kind of orange line, that started in late 2017 and is still basically bubbling away in between the two causeways. So much longer duration. So things have not improved, in fact, potentially gotten worse. And if you look at light, again, how much light reaches 1 meter, you can see that it's just gradually starting to fade. That's the super bloom dip there. And so we've been below 20% for a fair bit of the time. And you see a response in seagrasses. So again, this is all the IRL, so it includes the southern parts, but even there they've had issues. So again, here we go. There's the dip for the super bloom. 13, 14, 15 were moderate years, and seagrasses did try to make a bit of a comeback, but then dropped again here in 17, and now we're about 48% of what we had in 2009. So we've got over half gone. So with that amount of change, did we see flow-on effects, as I'll call it? Did other things change? So one of the key things that seagrasses does is it offers a habitat, particularly for a lot of juvenile fish, so they can hide from their bigger carnivorous brothers. And so we looked at here just some data from the fisheries independent monitoring that goes on in the lagoon, done by the Fish and Wildlife Conservation Commission. This is one type of seine net that catches, it's a small seine net and catches smaller fish. Code goby is a very seagrass-centric animal. And you can see here that they were ticking along. There's the dip following that loss of seagrasses. They sort of tried to make a comeback as seagrasses tried, and then they dipped again. So with these recent blooms, we're now, we think, starting to be able to discern signals further up the trophic web, as it were. We couldn't do that with just one change, but now that we've had sort of several periods of stress, we're beginning to see those effects potentially. This is juvenile snook, caught in a slightly larger seine. And you can see here the numbers go up and down, as they always do. But then there's a dip for that super bloom. Then they're sort of ticking along down at this level. And then there's the dip here with the more recent blooms. So again, they didn't show quite the comeback. So we may well have had enough change that we're seeing other things in the system change as well. So now let's go back and see if we can figure out what went on. This is a conceptual model that just helps me organize my thoughts. It was created by Duarte, and it's called the Eutrophication Progression Scheme. It applies to lots of places, freshwater and saltwater, and it's particularly focused in on systems that have rooted macrophytes. So seagrasses or Vallisneria, some of the freshwater grasses. So those are things that were terrestrial plants that then migrated back into the aquatic systems. And so they have certain characteristics that make them good indicators of stress in those systems. So in this thing you have loads of nutrients, which we've done lots of places, have increased. So you're getting an increased nutrient delivery, but you may not immediately see a change in the system. And that's because in the system are this range of what I'll call buffers or shock absorbers. And so those nutrients get cycled, they get taken up, say, by phytoplankton that get grazed by things like oysters and clams and zooplankton. They cycle, so they get taken up by seagrasses and they're held for a fair period of time, or drift macroalgae, which we'll talk about in a bit more detail. They also get bound, particularly phosphorus gets bound to particles and gets pulled out of the system. So you can put nutrients in the system and not see much of a response immediately. Then typically what happens is either the nutrient delivery increases too much and it overcomes those buffers, or one of those buffers changes in some way. And so then the system progresses fairly rapidly from having seagrasses in our case to enhanced growth of either in different systems, phytoplankton, which is ours, that's a Secchi depth. So I don't know if you've ever knew much about secchi depth, but they lower a disc and figure out how deep in the water column it can go before they lose sight of it. Well, that's 0.2 centimeters, so that's about 4 or 6 inches. That's the kind of phytoplankton blooms we were seeing. Macroalgae is another thing that can happen. So those things are all kind of up in the water column above the rooted macrophytes, typically, above the seagrasses in our case. And so they shut out the light. They shade them. The other thing that you get typically as well is when those phytoplankton die, they go to the bottom, they start to rot. That uses oxygen. The bacteria use oxygen to do that. And so the benthic respiration, as we call it, goes up, which means the oxygen levels are lower. Seagrasses and the other root macrophytes, one of the characteristics they have is they have roots that help them take nutrients from the sediment. That's how they compete in low nutrient waters. Those roots get poisoned by the hydrogen sulfide that forms when you have this low oxygen system. And then between that and the shading, they get squeezed out of the system really rapidly. So that's why the system changes quickly. And you get seagrass loss. So what we're going to try to do is kind of walk through some of those different potential reasons for change in the system. So external loads, the kinds of loads that we worry about in the total maximum daily load process, typically, are what I'm calling external loads, so stormwater and things like that. Other things are in there, but they're in there implicitly, not explicitly. So external loads are typically driven by rainfall. So this is rainfall in millimeters, monthly rainfall in millimeters, and this is a period of interest here. So just pre-2011. And you can see that in all the different parts of the system, the rainfall wasn't particularly high. So we're not likely to see a big drive of external nutrient loads. And in fact, when you look at total nitrogen here in pounds per day and total phosphorus in pounds per day, this is our period of interest. And the loads are still there, but they're not exceptionally high. They're not unusually high. So it doesn't look like the loads came from outside, came from the typical smoking guns. So we did, however, see changes in the system. So this is dissolved phosphorus, and this is dissolved nitrogen, which you just heard about. So that's ammonia and organic nitrogen. And these are the three systems, the three lines, and then these bars, these horizontal lines, those are averages across all those years. So pre-2011 and post-2011. And we saw a step up in phosphorus. We didn't see the same sort of step up, and potentially a little step down, actually, in nitrogen. So something happened in the system that we weren't seeing from outside. It was an internal thing. And we can go a little deeper, and we can look at, well, what kind of phosphorus was that? So this is total, and here's the PO4, or the soluble reactive phosphorus, the type that you typically see phytoplankton take up, and it didn't change as much. So what we think we're looking at here is some sort of change in organic nitrogen, nitrogen bound to carbon. And when we then go back and say, well, does this kind of correlate, as it were, with what we see in terms of phytoplankton? So here we have the orange line is the phosphorus on this axis here, and the green line is the chlorophyll. And you can see that they track each other. So when phosphorus goes up, chlorophyll goes up. This is the same thing, but for nitrogen, the blue line. And you're not seeing that. You're not seeing the kind of changes, the spikes in nitrogen that are driving this thing. So we see the phytoplankton respond to the phosphorus. That's just one place, but it was true in multiple places. So then that leads you to ask, well, where did all that phosphorus come from? Why are we seeing this phosphorus? And this takes us into this perfect storm argument that we had about the superbloom. The fact that when we looked back at conditions that led up to 2011, we saw that there were several things that were a little bit unusual to happen all together, as it were. One of the key ones was in terms of temperature. So this is mean daily water temperature. This is from Haulover Canal. We had 2 cold winters, right, and 2 relatively warm summers. So kind of extreme conditions going both ways in the lagoon. And some of that led to some of the events that we saw. So there was a cold kill in January 2010. The best numbers come from the NASA area, where they actually went out and tried to collect up all the fish that they could. And they estimated that they were looking at 400 tons of fish. So if you assume that there's 4% nitrogen and 0.4% phosphorus, and that's just relatively typical for composition of things like fish, you're going to get 16 tons of nitrogen released from rotting fish and 1.6 tons of phosphorus. So that's just for their part of the world. So they thought, well, if you kind of multiply that out, because the fish kill was bigger than that, you could potentially triple that. So was that going to give us the phosphorus that we saw? Well, it certainly would. But one of the hassles is that, remember, we didn't really see the change in nitrogen. So now we have to decouple those two. And that's possible. There's phosphorus is, I guess we call it a lot more conservative in the system. Nitrogen gets processed, and it can be called what's called denitrification, where it actually is released as nitrogen gas, goes up into the atmosphere, which is nitrogen gas is really stable, doesn't react. Plants can't use it as readily. Some can, they fix it, but we'll get to that later. But anyway, so So one of the challenges is trying to decouple the nitrogen and phosphorus release. We also know from a lot of work by John Treffry, Austin Fox, and we also have Bernard Regal from Nova University help us try to map muck. So you guys talk a lot about muck. So we know it's out there. We know it's a source. We now know, I think, a lot more about the temperature effect on this. So as the temperature goes up, the flux goes up. You get both phosphorus and nitrogen out again. And so once again, we're still stuck with this issue of how do we decouple those two? How do we get phosphorus without getting nitrogen? Well, there is a pH effect also. So as the system, the pH goes up, becomes more basic, you'll get a flux of particularly phosphorus because of the chemistry of the phosphorus that's bound to the particles. And what happens to the pH? That goes up as the algae draw CO2, the carbon dioxide that they use as their carbon source, out of the water. And so you may get a flux of phosphorus as that biomass, algal biomass, increased. So what we might have been seeing was a response to the bloom gearing up. But this, again, is going to be mostly inorganic nitrogen phosphorus, right? So it's that SRP and inorganic forms of nitrogen. So we're still left with trying to figure out exactly where some of this phosphorus came from. And in fact, our sampling may not quite have the spatial and temporal resolution that we need to go find some spike like that. We just don't, we're not out there enough at enough places to figure that out. But one of the other places we can look for getting nitrogen and phosphorus into the system, and it can tend to be organic, is an internal source, which is drift algae. So you have macroalgae that are not attached. They roll around the lagoon. They may roll up in your backyard. People don't tend to like that as they rot and they tend to smell. But we know that there can be a large amount of that out there. People don't sample it particularly. It's typically bycatch and some other sampling. So the folks from the district record it as they do seagrass transects. They try to record the amount of drift algae that they see. Here we're looking at the fisheries independent monitoring. When they go out and pull their seine nets, they'll often pull in a lot of drift algae, and they try to figure out how many buckets of drift algae they catch. And those are the data we're using here. So this is a small seine. It doesn't go as far offshore. This is a slightly larger seine. It goes out a little further. But you can see that around that 2010-11 mark, the amount of drift algae, and this is grams wet weight, is down in these systems. So if the drift algae actually died, it would release nitrogen and phosphorus, like all things do. But if nothing else, we're at least looking at a change in the way nitrogen and phosphorus are going to cycle. So drift algae are not available to take up nitrogen and phosphorus, which means there's going to be more of it left for other things like phytoplankton. So that's the way we're thinking about how this works now, and we'll go through that a little bit. So one of the things we tried to do was say, well, we saw, remember the temperature, we had cold and warm. So does that bother drift algae? We know drift algae are a little bit temperature sensitive. So we took a look and we did experiments with drift algae in tanks. This first experiment focuses in just on temperature stress. So we have temperatures 7, 10, 25, and 33 degrees, and 3 different types of drift algae. So what we learned from this is this one, Acanthophora, doesn't like tanks at all, didn't grow to speak of. This is growth, cumulative growth in grams dry weight. Gracilaria, which is relatively common, and Hydropuntia, another common one, they show this kind of Goldilocks effect. So there's an optimum, right? They grew best at about 25, and they grew less than that, either colder or warmer. But that wasn't the only stress that was out there. As soon as the phytoplankton started blooming, the light also started dropping off, the amount of light that reached the bottom. These macroalgae need light just like every other plant. And so we looked at the combination of the two, temperature and PAR, the light. And once again, we didn't see mortality. You just saw less growth. So if you look at this graph, these are low light values over here. So that's 10 microeinsteins per centimeter squared per second. And over here is 250. Oops. Targeting. Over here is 250. And so if you go from left to right, you can see that they tend to grow more as they get more light, and that makes sense. And it's up only when you get kind of up in these upper ranges that you see that kind of temperature effect, the Goldilocks effect. So once again, our evidence isn't that we had a massive mortality of drift algae. We just might have had less growth and therefore less uptake. So the cycling change, which was one of those shock absorbers that I listed at the beginning. We can try to take a look at that a little more by looking at the 3 key primary producers that are in the lagoon. So seagrasses, drift algae, and phytoplankton. And what this is all in terms of carbon now, grams per meter squared, so that we can get them all on the same footing, use the same units. So this graph on the upper right, that's the seagrass, that sort of surface. And you can see here the super bloom and then the later blooms, and that's where we lost our seagrasses. We come down here and we look at drift algae, and again, you had the dip just before the super bloom, some recovery, and then it's been low. And then if you look over here, we have the blue line, and that's the phytoplankton. And it fills in the gaps, just sort of the way you might expect it to do. So what we think we're looking at particularly is that the system essentially, and okay, I should mention first that phytoplankton probably drives a lot of these things, right? So when phytoplankton get really abundant, the light goes down, and that's going to keep or push the drift algae and seagrasses down. So what we've seen is this shift where the system is essentially much flashier. So it just responds much more rapidly because the seagrasses and the drift algae that kind of sucked up nutrients and held them for a longer period of time aren't doing that as well anymore. Once again, have there been other changes in what's going on in the lagoon, particularly with the phytoplankton, because that's where our issues have been arising? And the answer is yes, there have. So in the good old days, the blooms were mainly, this is carbon again, the blooms were mainly diatoms and dinoflagellates and some larger cyanobacteria or blue-greens. And so diatoms are the ones that use silica. Dinoflagellates, one of those is pyridinium. That's the bioluminescence that everybody likes to kayak through. And that's what we tended to have as blooms in the old days. That shifted. And you can see that here. This is Banana River Lagoon. This is the brown tide of 2016. The first brown tide was in 2012. That was in Mosquito. That's the super bloom, that little green blip. And that was a change to these green nano eukaryotes. So they're relatively small. You get about 200 of them across a period on one of your pages in front of you. So what we've certainly seen is a shift in who's out there. This is the 2016 brown tide that caused the large fish kill in Banana River Lagoon. And, we still see dinoflagellates and so forth blooming, but we have these kind of new players. And so what we found out through time, as it were, is that, yeah, we're definitely seeing a shift in the composition of the phytoplankton. They tend to be smaller, so this is going down to the new dominants. That's the brown tide at the bottom there. This is these mixed greens here. And what we've seen for the cyanobacteria is they've shifted to picocyanobacteria, which are smaller than the nanos. So these are really quite tiny. So everything seems to be, the dominants seem to be smaller. Smaller phytoplankton turn over faster. They double faster because there's not as much biomass to double. The brown tide itself has what we call a resting stage, where it'll kind of settle out of the water column, and it just sits there. It sort of goes into kind of a hibernation almost, and it just waits for conditions to become right, and then it can pop back up. And so that means you don't have to have it inoculated from anywhere. It's like just waiting there on the bottom. Some of these players down here use, again, the organic nitrogen and phosphorus. So remember back, we were looking for the organic phosphorus, and some of these can use that. They can strip the nitrogen and phosphorus off carbon molecules without having to wait for the bacteria to do it. So that means, once again, they churn a lot faster. And they don't lose some of that nitrogen and phosphorus in the conversion. So in combination, some of these things are what give us the much more intense blooms and the much longer blooms, because they basically churn on themselves. Brown tide just feeds on its dying brethren, as it were. It's possible, there's some evidence, and this is hard to get, that the picocyanobacteria can fix nitrogen. So remember I said nitrogen gas is relatively inert and it's hard for these things to get hold of. Well, these, and like legumes, can fix nitrogen. They actually have, in legumes it's bacteria. Here it would be the cyanobacteria themselves. They can take nitrogen out of the atmosphere and bind it to carbon and make it useful. So once again, they avoid the issue of how do you get hold of the nitrogen. When we looked, one of the things that we worried about was top-down control, so the grazing. Because these were new players and they're relatively small, did we see changes in the amount of grazing that went on? Because that's the other side of the control. So bottom-up is controlling the nutrient inputs. Top-down is controlling by having something eat it. Microzooplankton did okay on most of these. Not necessarily great on some of the smaller stuff. Particularly brown tide, which can secrete a mucus, a kind of what they call an exopolymer, so outside of its cells, and that may slow some of these grazers. And it may actually even bind and clog up fish gills and filter feeders, shut down and wait till the brown tide goes away. Mesozooplankton didn't eat some of these things at high densities. In fauna, like clams, did okay, but again, except for the brown tide, which they tended to sort of just try to wait their way through, as it were. Epifauna, various other epifauna, sponges and other things that filter feed, again, did okay except for the brown tide, and they would definitely eat anything else first, and once again, probably because of the mucus. So again, we're seeing not only probably a change in the way nutrients are handled, but a change in the way phytoplankton's controlled by grazers. So, does this mean anything to anybody? Which is the question that I always get asked when I do this for my executive director. And the answer is maybe so. So, nutrients leading to chlorophyll, that's still the issue. So, everything you folks are doing here and all the stuff that other folks are trying to do, that's still on point, right? You don't have to change what you're trying to do. However, this concept of applying a total maximum daily load to the system, we may need to dig a little deeper than that if we want to understand how the system's responding. That's still an applicable tool, but we may want to know a little more, particularly as we go down the track. And if we're not seeing the responses that we'd hoped for, we can at least talk about why that might be. We know now that the new sources of chlorophyll are relatively bad actors compared to the ones we had before. And that helps, in my mind, say, well, you might want to have data a level below just chlorophyll. So, chlorophyll's a good tool to guide a lot of things, but we may need to know a little more, again, as we go forward and we're, kind of running out of options, or we're thinking hard about what options to go to next. That the super bloom was probably a combination of a perfect storm and a somewhat new norm. So something in the system has definitely seemed to have changed. Now, will it stay that way? Well, we'll see how we go. I mean, again, nutrients are being reduced, and we may see it come back, and get to that in a second. One key thing for me is that events matter. So the total maximum daily load process and almost all our management processes focus in on kind of average conditions over somewhat long time periods. And what we've seen here is that an event made a big difference in the response of the lagoon. Didn't take much to make it change. There might have been an ecosystem shift, and that could lead to a challenge to restoration. So let's just walk through how I'm thinking about this. So if we look at, on this axis here, quality of some kind, whatever is seagrass extent, for example, and here's stress, low, medium, and high. So systems, as the model said, get stressed, and they don't show much of a response until eventually they get overstressed. And then they go down, and what we're seeing potentially here is a new regime. Now the TMDL process says, well, what we want to do is push back on the stress. Whoops. So we push back on the stress, and our hope is it goes back up this slope. Well, that may not be true. So what we may see is that we have to push back further because the same sort of lag, as it were, that was in the system to start with is in the system now. And so we may have to push it back further, lower the stress further than we thought to get it to respond. So patience. Don't think of this as a sprint. This may well be a marathon. Okay, so quickly, what can we maybe do? What can we maybe invest in to help us move forward? Probably some better understanding of what I've called internal loads, but they're just kind of what I would call implicit loads that are in the way we think of things at the moment. You guys have done great on Muck. Groundwater is another one we've been looking at. This is just one measurement taken by the USGS. They looked after the hurricane, and they saw that 150 meters of shoreline that ran for 10 kilometers, so 150 meters and 10 kilometers long, 7% of the St. Lucie River flow at that max flow. So groundwater definitely comes in the lagoon. We don't see it, but it's coming in. And that may carry nutrients with it, so it's something we may want to understand in the future. And all that may just help us adjust the total maximum daily load. Drift algae, again, take a look at how it works in cycling. It may even be a tool. We may be able to harvest it to get nitrogen and phosphorus out of the system. Now, it is also habitat, so there's pluses and minuses there. Phytoplankton, understanding some things about N fixation and how these different species respond to the ratios of nitrogen and phosphorus may become important as we go forward, because we may unbalance the system by removing too much nitrogen and not enough phosphorus, or vice versa. And this understanding of how they interact with organic and inorganic, because organic and inorganic come from different places. Filter feeder enhancement, yeah, certainly some, I would say, build towards being able to do that, because that'll help you in the long run. Just as with seagrass rehabilitation, which is something that got into the plan. Build towards it. We're probably not ready to go out there and plant tens of thousands of acres of seagrass right now. Water quality is probably not stable enough, but there's a lot of things we might want to know about how to do that before we get to that point. So while I take a breath and you ponder your questions, this is what the seagrass change looks like in banana.
I'll start with a question. You mentioned, it's kind of news to me, that there's not much that's eating brown algae. Where brown algae are maybe more indigenous, are they consumed in the food webs that they occur naturally in by sponges and filter feeders?
Well, okay, so they are consumed. I wouldn't say they're unnatural here. It's that we haven't gone back all that far, but we certainly went back before the brown tide dominance, and they're around. I mean, again, they're really small, and when they're in low numbers, they go into the kind of other category because there weren't enough of them to particularly highlight. But But there's no evidence that they just suddenly appeared in 2012. They just never were dominant. Now, what caused that switch? Well, that's probably got a lot to do with this sort of switch between availability of nutrients and so forth and so on. Laguna Madre is another place where the species we have bloomed, and they showed the same kind of characteristics, long, fairly intense blooms that just sort of never seem to go away. So they're not atypical. The grazers there struggle as well. This is something that, and what causes the mucus and how much is produced is probably yet to be determined. I think stress of any kind will lead that to happen. So yeah, they're problematic everywhere. Yes.
Anybody else?
Yes. Is there any way to harvest them out of the water?
No simple way that I know of for a range of reasons. One is the volume of water, and two is the side effects that you might create by trying to filter all that water. No. And again, I think what's important to remember for nutrients and things like the lagoon is that, again, you're looking at a Goldilocks solution, as it were, right? So you want just enough nutrients to keep the system productive, because the nutrients drives that productivity. You're not going to get snook and redfish and sea trout and whatever if you don't have those nutrients. So you don't want it to become like the open ocean. You want it to, but that means that you're trying to sit on this little point, as it were. You go too far one way and, it becomes more eutrophic, and that's kind of what we're seeing. Sorry?
Fall off the cliff.
That's right. Or too far the other way and there's not enough productivity. So that's an issue.
You mentioned a couple times that we need to take a closer look at TMDL. Can you describe further in detail what the mechanics of that would look like? Who would have to do what?
Well, I think first of all, I have to make myself pull all this together so that it's a coherent story. And we're doing that, and we're getting so one of the things that happened with the investigation is we didn't quite get the leeway to synthesize this. So we took this kind of puzzle and we broke it up into little pieces and farmed them out to people who could, refine our understanding of those pieces. Now we need to bring that back together. And I think that would then feed into the TMDL process. TMDLs get reviewed every 5 years. We're going to probably have a fairly extensive review of the TMDLs in this region for a range of reasons. One of which is that seagrasses no longer look like the sole available metric, and we may have to come up with something else that gives us a little better handle on where we're going. But that's what I would say is we'll pull this together, we'll talk to the TMDL folks, and we'll feed it in the system. I think a nutrient budget is probably a first step. So there are times when I feel like I have 3 to 5 halves of a pie, and I don't know how to make them fit. We started that process. It's a little harder than it sounds, but we'll keep that up.
What about the effects of herbicides being used? We just had a presentation before about azartine, which is a herbicide that's used for St. Augustine and stuff like that. But it's also, what about the effect of the water management district spraying herbicides in the feeder canals to kill off cattails, which also have a really great uptake of phosphorus, which is one of your first fighters in getting phosphorus into the lagoon and stopping. Have we looked at the correlation of the use of herbicides with the kill off of the seagrass? Because I know that's really susceptible. I'm pretty certain it's susceptible to herbicides.
Yeah, in that kind of detail, we haven't. But the evidence that I've seen, and people have been pulling together more evidence, again, is that we're unlikely to see that for a range of reasons. One is contact time. So, up in canals with direct spraying, and sometimes they even, slow the water flow down in order to get at those plants. But once you mix that into the lagoon wide, now, your concentrations are really low, and the contact time with any given plant is relatively small.
Well, he just had where they actually had there's azartine still in the muck that they actually have detected. So.
Right. Well, some of these things persist, so, they're going to be there. The question, I think, is, are they at enough concentration to be biologically important? And I think the comment that was made when the question was asked about, are these concentrations of concern, is that no, none of them were. I mean, like sucralose goes through every process that we have.
that's true.
So, but some of the others stick as well. But yeah, it's some. I know glyphosate's become a big issue, and I just spoke with one of the aquatic weeds guys from Fish and Wildlife the other day, and they've tried pretty hard to pull together data to get an idea of how much phosphorus it might contribute if you took the worst case scenario. And they did that for Lake Okeechobee in particular, and it was less than 0.02%, I think, or something. So again, just you think there's a lot out there, but in a relative sense, there isn't. So
Have we looked at how much glyphosate, for example, is killing our seagrass?
no one that I know has looked at glyphosate effects on seagrass. But once again, I would be surprised if the amount of glyphosate that's being used and the way it's being used would cause a major effect on seagrasses. We're pretty certain that light was the cause of what we've seen here for a range of reasons. So, but I mean, that is something that we probably should take a look at. Just exactly what is that effect?
I've heard that it's used in pretty high amounts, so.
Again, I think it's used in pretty high amounts in given areas, but once you dilute that with the amount of water that you're putting it into, it's not in high concentrations anymore.
Okay.
Thank you. Any further questions?
Yes, I'm sorry. Very quickly.
One more.
Besides the normal nutrients, the nitrogen and phosphorus, does either phytoplankton or brown tide really have any other strange limiting factors known?
Diatoms are limited by silica, which is one of the things that probably often led to their blooms, crashing off relatively early. No, not particularly. I mean, there are a range of things that they need, carbon, but that's in plentiful supply. Nitrogen and phosphorus are the two that call the macronutrients.
The main ones, okay.
Yeah.
Thank you.
Thank you, Dr. Jacoby. Appreciate it. All right, so it looks like we can jump to the Cone Road video. I think it's about 2 minutes.
Asset sales tax approved by Brevard County voters in 2016 will pump more than $480 million toward restoration of the Indian River Lagoon. But the investment in one of the county's most prized environmental amenities and economic drivers doesn't end there. Other local and state funding in the form of grant dollars is also involved in the improvement project that focuses not only on removal of pollutants that have built up in the lagoon over many decades, but in preventing other pollution sources such as stormwater runoff, septic system effluent, and storm-related sewage backups from tainting the future health of the lagoon. One prime example of how multi-agency partnerships can benefit the lagoon is underway on Merritt Island. It's a multifaceted initiative called the Cone Road Project. This three-phase effort utilizes financial resources from the Merritt Island Redevelopment Agency, the St. Johns River Water Management District, and the Save Our Indian River Lagoon program. The project phases include conversion of more than 80 commercial and residential properties from outdated septic systems to a new county sanitary sewer system and sewer line, construction of stormwater treatment infrastructure, and a water quality treatment system that will divert untreated stormwater to a treatment pond and denitrification bioreactor. Other features include a sidewalk over the pipe ditch along Cone Road that will improve pedestrian access and vehicle safety, and a sanitary sewer main that will serve more than 60 parcels within the Cone Road industrial area. Upon completion, the Cone Road project will prevent over 3,000 pounds of nitrogen and almost 200 pounds of phosphorus, both cited as major causes of algal blooms, from entering Banana and Indian River lagoons annually. It's also estimated the project will benefit the local economy, generating capital investment and creating additional jobs and strengthening the tax base. With one three-phase project, these agencies are combining forces, funding, and resources to improve local infrastructure, treating stormwater runoff into the lagoon, improve safety, remove blight, improve property values, and most importantly, preserve the future health of the Indian River Lagoon.
video.
I was just going to ask if you wanted, a couple years ago, we did a field trip to the on-site wastewater field station. If there was interest in having a field trip to the Cone Road project, Public Works and Merritt Island Redevelopment are willing to talk about their, components, and we could advertise that and go through all the process, but don't want to do that unless you want to go.
I would be interested, but I don't know that one man makes a field trip.
Well, I'm definitely interested. Do we need a motion to make this happen? So I would so move. Needed.
So like 3 weeks out, are there days of the, should we do it on a different Friday morning, or?
When we did the septic fuel tank, didn't we do the day of the meeting and we just left early after the meeting? Isn't that what we did?
I think so.
Would that work in this instance? I don't know, I'm just throwing that out there.
That was when we were having shorter meetings.
Yeah.
Did we ever have shorter meetings?
I don't think we have.
I was just saying.
He's being nostalgic.
I think we also met in June, too. We're not meeting in June this year.
Right.
Yeah?
Yeah, so we could schedule this for a Friday in June.
Sounds good.
It'll be warmer then, so I was aiming for earlier, but
The project will be somewhere still,
under construction.
Under construction, good for us in June to visit? Okay, we can agree to something in June. Do you have a motion, Lorraine, on that? Do we need a motion on that?
Yeah, I'd like to make a motion to have a field trip in June on a Friday, although I only have 2 Fridays available, so I'm going to say those 2.
Well, that can be determined, right? Do we have a second in support of a field trip in June?
Second.
All right, we have a second. All in favor?
Aye.
Any opposed? All right, so, sorry, John?
I'm not opposed now. A motion to extend the meeting.
Yes.
15 minutes.
15 minutes? Brandon, how long is your presentation?
I'll try to do it in 15.
15? Do you need a whole 15? Because we're going to need a few minutes after that. So, 20?
30 minutes.
30? All right, so we have a motion for 30 minutes from John. Do we have a second?
Second.
Danielle, all in favor?
Aye.
Opposed? Okay, thank you. Proceed.
All right. So to go over the performance table that we discussed a little earlier, just to give you a general idea on how it's set up. So we sorted the projects on there first by the entity and in alphabetical order, and then by the project type. So that's the sorting just in general. And you'll notice there's a breakdown between the county projects. It's a little different than the ones with the outside entities. So with the county projects, we are able to track them a lot more closely since our staff is on site. So we know when we are contracting in the engineering and design phases versus the construction phases. With the city entities, they don't necessarily give us that detail. In their quarterly reports, they'll tell us, we're in design or we're in construction, but we don't have that on a regular updated basis. So because we were only doing the county at that level, we divided those out. So we had engineering and construction just to show progress on those. Also, it was a way to show the progress since we don't have a single contract with the county ones, and we're tracking contract progress. We do a contract with the engineering firms, and then we have another contract when it comes to construction time, so that way you can track those individual contracts. All right, so going through the categories, so the first one, the grant confirmation notice is sent out. That's once a year after we approve the plan at the county commission level. Then I send out a notice to all the entities that your substitute projects have been approved. Here's all the paperwork you need to get them started. And then we wait for them to send back their scope of work. So the scope of work is attachment A of their contract. And they fill out that. If it's a non-county entity, of course, we don't have that at the county level. Instead, there's discussions that happen with the contractors that we'll develop a task order with. So instead of a cost share contract, we do a task order with a contractor, whether it's the engineering firm or the construction firm. And so when we have those discussions, that's when we mark that the scope of work is received on the county level. Once I get the actual document back from the cities, we mark it in the outside entity. And then for preparing the contract, that's the task order level at the county, and then the cost share contract for the outside entities. So that contract is prepared and sent over to our legal department to review, and then it gets, after they review it, it goes through signatures at the county level, so it gets reviewed by the county manager and then goes to the chair and the clerk for signature. Once those are signed off on, they're sent to the entity themselves, and that, depending on the entity, it can be as easy as the director of, say, the Brevard Zoo signs it and sends it back, or often with the cities, they then have to put it in front of their council, and they have to approve it and sign off. Some cities will do that ahead of time, so they'll request, when we're developing the contract, they get a copy of what we're submitting, and they'll try to get it ahead of time so that once they get the signed one from the county, they can just send it up for a signature instead of having to wait for it to go on an agenda. And then we'll mark the project complete once all the construction is finished. So that doesn't mean that all the paperwork is finished with the project. They still might have final reports that have to come in and final reimbursement requests. But once all the construction has been reported complete and we're seeing a nitrogen removal benefit, or nitrogen and phosphorus removal benefit, then we'll mark that as complete. So the reimbursements, I think one of the reasons too these were at the end is these were asked to be added in later when we first developed this, and then we wanted to get the reimbursements in, so we just sort of tacked them onto the end. And initially too, we didn't report the percentage reimbursed, and then that was added in later. So with the reimbursement requests at the county level, that's an invoice that's sent to us by the contractor for that task order. At the non-county level, they have a form they have to fill out, which is an attachment C in their contract. They send that to us along with proof that they've paid out all the invoices that are in there. So they have to show the bank drafts and everything from their system that they've paid those out before we'll send that reimbursement. So that then goes through our finance department, and once the check has been cut, that gets recorded as paid out, and that's the percentage you see there. So sometimes there can be up to maybe a month delay between when it's asked for reimbursement and when it gets paid. Then we have our color coding. Now for ADA compliance, you cannot use color coding alone to designate something. So you have to have some sort of text in there. So where we have used a different color, we have used text just to show that that's designating when those projects are going to be expected. So the green is what's complete. The yellow is the ones that we expect in this fiscal year. And then the blue are future fiscal years that we're expecting the project. And then we have the dreaded red. So those are the ones that were a previous fiscal year and have not happened yet for whatever reason. The two that are on here that are red currently, it's because of variances they've been trying to get and haven't been able to get those to start forward with the project. So they're trying again this year, and if not, might have to drop that. But luckily, we haven't had too many in the red yet. And then I was asked by one of the members here that if we could do some sort of legend, and since it's legends would be color coded, we would have to put in a texture as well. So it's a little hard to see on here, but there's 3 different textures in the bottom examples. One has dots, one has horizontal lines, and one has diagonal lines. So we can do something like that if we do a legend, or we can just put the word complete in to each of those text boxes, the green ones. that would make it ADA compliant. Now, the word complete is actually technically in each of those boxes so that the readers pick it up, the screen readers. It's just the same color as the text box so that it doesn't make it look too cluttered. But if you guys would like, we can go to that. I would suggest the top one over the bottom one just because it becomes a little harder to read when you do the textures along with the text. So then at the end of things, you have your category totals, and these were done on a monthly basis. We'll switch this to quarterly now so you can see the difference, the change in those totals. Now keep in mind that these totals are not totals for the number of projects, because if you remember at the county level, we had it divided up into two different sections. So this is counting the number of contracts that we have going on with that project. So it's the engineering contracts and then the construction contracts at the county level. And that's pretty much the overview. So if you guys have any questions on that.
Well, are you soliciting our comments on what to include in your color coding? It sounded like you were open to.
Yeah, if you, in this,
This entire report was created in response to requests from the COC. So
That's right.
if it's not what you want, I mean, the only reason we're doing it is, well, I mean, there are multiple benefits for doing it, but
I had a question about the color coding, because in looking through and I think I've asked this, maybe I sent you the email about it. There's nowhere in the report that suggests what a red, a yellow, or a green color means.
yeah.
And so even if it was just written in words on the very last page of the report, I think that would be useful.
Yes.
I mean, I know what the red, yellow, and green means, but I'm not sure.
So
other
we
people-
can't do that in a legend without adding in the textures as well.
No, but I mean.
Because someone who can't differentiate colors, if they're colorblind, they can't look at that table in the end and say, okay, green means complete. So we either have to add the word complete in to that or add textures into each of those
In
boxes.
that case, I withdraw my question, and I make a recommendation, you do nothing with the table, because it's just going to take more time and effort, and it's not worth doing.
But I think your point was in black text.
Yeah, black text.
Somewhere, we could say, green means complete, yellow means whatever.
But I think what Brandon's response was that if you tell them it's green,
Then you
they
have to
might
put the
not be able to
texture
see
in.
green.
Yeah, they can't see
Okay.
that.
So ignore my request.
So the other way, like I said, we can do it like we do in the top and just put the word complete in there, and that'll make it more obvious that that's what the green is.
And in yellow, you would put.
Well, I mean, they
know,
have the text
expected.
in there.
They already have the
2019,
text.
yeah. And
Yeah,
in
so
red
the-
you do too? Oh, and
Yeah.
every other color you do except green?
Yeah.
So you can just put complete in the
Yeah.
green box?
That's all we need. Yeah.
Well,
And that's easy for you?
Oh, yeah, it's already in
It's
there.
already there. It's just in green
Oh, I
font,
gotcha.
so,
Yeah,
Let's
it's in
switch it to
green.
black.
yes.
I was going to say, you could also just say, you know,
it's green.
green or a blank box means it's complete.
Yeah, but if they see the yellow or the blue boxes, they look the same as the green boxes if they're colorblind.
Right, but if it doesn't have anything written in it, it's complete.
Yeah.
That's my point.
Okay.
Brandon, was there any reason you didn't make it black from the get-go?
Clutter, you said.
It
Just
looks
clutter.
It
cluttered.
looked,
It looks
we were
cluttered.
trying to, initially when we created it, we just did the colors and then the ADA compliance kicked in. And so we were we added in the words into the
I'll make it
yellow and
black.
blue
I'll-
boxes to differentiate those.
I would say make it black, and for the committee here, you know, I know it's easy for us, you know, I know what I'm looking at, but I have people who want to see this, you know, and I hand it out to a neighbor and a friend down the street, and they like to peruse it. Well, you know, what they do with it, I don't know, but they ask for it. So, thank you.
So if you make it black, though, you've got to make every block that's green, black, the word completed, right? And
Yeah.
that's what the legend looks like.
It's already, I mean,
Right now, it's green,
Yeah.
but what I'm saying is that if you create, just by the act of creating a legend, now every block will have the word completed in black in it.
yep.
You're saying it has the word completed in green. Now, the ADA reader picks up on that. So
Yeah.
Yeah.
I personally think this is fine, and I would not want to see it cluttered by having the repetition of the word completed through all these cells. We know what it means. You handed out to somebody who asks for it, and it's pretty simple explanation. That
It is.
says, so I'm with John. I think we're good to go.
Keep it simple.
I have a question that has nothing to do with this, but regarding the monitoring of removal and those efforts, how are we tracking that and how are we providing that information to the public?
So all the projects are based on estimates ahead of time. You saw Claudia's presentations on monitoring that we're doing. So we are monitoring a subset of projects, but you don't just, build it, take one sample before, build it, take one sample after. So I think there is nothing where we have completed all of the post-monitoring samples and have a final report to share with you. So that's why you haven't been seeing those yet. Obviously, as those reports are completed, we'll be sharing those and making them available.
It'll take some time. Is there like a timeline of expectations?
So the breeze swept was the first project completed. All that data collection has been done. The final report is drafted. The client is, in this case, is Rockledge. The Lagoon funds are funding a portion of that monitoring. The city is also funding a portion of that monitoring. So the report goes to them. They're reviewing it, providing edits back. So, when the final report is done and the city has approved it, then we will have it. The larger groundwater study, that one is due in November. Long Point Park, I believe we may be finishing that one up here in the next couple months.
Okay.
So
I'll wait.
you'll start to see them.
Okay, thank you.
Okay, Brad, I guess you're not making any changes.
No worries. And in the future, if there is something you want to see added or changed, just let us know. And
Thank you. Okay, so moving on, looks like we don't have anything tabled for today for our old business or new business. Did anybody have any comments on that? No? All right, so we're going to go ahead and accept general public comments this time. I have two speakers today. First up, Dr. DeFries.
Good morning, Dwayne DeFries. I'm the Executive Director of the Indian River Lagoon National Estuary Program. I was here yesterday at the workshop and sitting here today listening to Dr. Listopd's and Dr. Jacoby's talks kind of reminded me there's a bigger story here that I wanted you all to make sure you kind of understood. We saw how complicated this is, both in the delivery of nutrients and pollutants from land, but also this really complicated biological response. And if you look at the work that Dr. Jacoby showed you, you see all that data and you kind of don't get a context of all the brain power, the people, the scientists, and the financial commitment that was made since 2011. And I just asked Chuck, because I wanted to make sure my numbers were right. That research was probably close to $10 million worth of research, and maybe doubled that with the in-kind volunteer work of scientists. So first and foremost, I want to not just applaud, but thank you for your continuing commitment to science-based, data-driven decision-making. It's a great thing when I come here because of the great work of your staff. You've been doing that the way it should be done, but I also want to urge you to think about the complexity and that spatial and temporal time frame to get the whole story. So you've got projects where you're monitoring in the front, monitoring in the back, and with some of the groundwater work, I'm looking at that going, I want to see that over a longer period of time, because there's a point you could say, well, we've got enough data to know it worked, and if we wind up, let's say, with a 4-hurricane season the next year, it could be a little different storyline. And so keep doing what you're doing. The more data, the better. There is a point, you have enough data to answer the question, but your commitment to monitoring is important, and that integrated strategy of looking over a longer haul, and your time frame is 10 years, is something I'm not seeing being done in a lot of places, and it's that very rigor of science that's going to help us do this job better. And as we move forward, I just want to give you a heads up. We are going to issue a contract to look at monitoring throughout the lagoon for next year and ask the big questions. Are we monitoring enough? Are we getting the data we need? Does it have the spatial and temporal, granulometry that we're going to need to make decisions? So we'll be coming back to you and Virginia and her team and all our partners to do that very, very tough work of gap analysis and see, do we have the information we need to make the right decision? So thanks again for all the hard work you do.
Thank you.
Thank you.
So just to foot stomp your point, yes, there's paralysis by analysis, but we are data deficient in understanding the lagoon. So I applaud the effort. We definitely need more data. From the MRC standpoint, we're interested in engaging our citizen scientists to be able to gather the data, help in gathering the data that we need throughout the lagoon. So keep pushing.
Yeah, and we have insufficient funding, across the board for this. There's no question that, a lot of this is driven by the availability of funds. And thankfully, Brevard County has made that commitment through the Save Our Indian River Lagoon program. Other counties don't have that same capacity. But this is a fight we will all fight together. This funding for research, funding for data acquisition, synthesis, and analysis, mission critical to what we're going to do. And it's going to be mission critical to our success.
Thank you. Vince Lamb.
I'm feeling a little guilty holding you at this point, but I'm just going to be a couple of 3 minutes.
So you're only going to use up all your time.
Okay. We're 2 years into this Save Our Indian River Lagoon project plan, and the Help Our Lagoon dashboard shows that 14,990 pounds of nitrogen have been removed or prevented. The brown algae that's covered the lagoon frequently since 2011 is not currently abundant, but it's hard to find evidence that the lagoon water quality is improving. Little analysis of mine, Brevard County has 15,000 residences that are within 50 meters of the lagoon or its tributaries or major canals. The fertilizer recommendations are 4 to 5 pounds of nitrogen per 1,000 square feet for St. Augustine turf. If you assume that the average yard has 4,000 square feet of turf grass, that maybe they apply 10 pounds of nitrogen annually, and maybe 2 pounds of nitrogen make it into the lagoon with storms. With these modest assumptions, the amount of nitrogen entering the lagoon from lawn fertilizer alone could be 4 times the amount that has been removed. Without comprehensive water monitoring, we don't know much about what the actual numbers are. It's hard to tell if the nutrients entering the lagoon today are any lower than they were in 2016 when we had massive fish kills that led to the passage of the half-cent sales tax. They could actually be higher. It's simply wrong to allow residents to freely apply lawn fertilizer that enters the lagoon with every rain and requires $1,000 or more per pound to remove them. Is it a coincidence that Tampa Bay, where 2 counties have real fertilizer sales bans during the rainy season, is a model for water quality restoration? Perhaps we need to convince our legislature to restore home rule and let us choose. Maybe we need to revise the Brevard County and municipal fertilizer ordinances to include fines and enforcement, which we can do. We've been hearing for years about the excess nitrogen in reclaimed water, but nothing has changed. Strong evidence suggests that these nutrients are entering the lagoon in large quantities. At the workshop yesterday, we heard suggestions of metering or perhaps charging residents for reclaimed water. We need a task force of leaders to find the fastest and best solutions for stopping the nutrients from reclaimed waters from entering the lagoon. Reducing lawn fertilizer applications and reclaimed water nutrients rank high among the lowest cost solutions to restore lagoon water quality. They're also probably the fastest to implement. I've long been a stay-the-course advocate on the SORL plan and the COC recommendations. I remain a strong supporter of county staff and of the COC, but I want to instill a much greater sense of urgency. I have lost confidence that the improvement is just around the corner. I encourage the COC and, of course, the Board of County Commissioners to take bold action. This taking baby steps and hoping for improvement just isn't happening. So think big, be bold, and fix the problems.
Thank you. Okay, we've come to final comments by the committee. Anybody have anything? Go ahead, Terry.
So just a couple things to tack on to Vince's comments about the fertilizer ordinances. I'll channel John Byron for a minute and say, it's not our job jar to propose legislation or ordinances or whatever. But as citizens in front of the commissioners, we certainly can do that. And this group is as informed and aware as anybody I can think of to visualize, as is talking about, what is it going to take for success. And I would add a couple things to the ordinance discussion. The first is something that John and I invented yesterday. It's the universal poop ordinance. And it goes something like this. If you live in a house in Brevard County and you're defecating in that house, then you have an obligation to the rest of us to deal with that matter. And whether it's a septic tank or a sewer system, there is an obligation. And while we may have ordinances in place, we all understand that the enforcement is the weak part of that. So whether it's through education, enforcement, public shaming, my point is I think we don't differentiate septics and sewers. It is both of those are vehicles for delivery of nitrogen, nutrients, and fecal matter into the lagoon. We need to stop that, and the obligation is with the homeowner. And we need to face up to that. And as Christina was talking about yesterday, it may be a burden for lower income homeowners. We need to be creative in talking with our commissioners and how we deal with that. The other one I would foot stomp is yesterday we heard Dave Botto speak to the limited impact development and the things, the smart things that we need to do in planned development. We know we're not going to stop development. We know that there are 1,000+ households a day that are trying to move to Florida. We need to put in place the right kind of planning, the right kind of requirements in the codes and in the development of property so that we reduce the amount of impervious surfaces, we capture rainfall, the runoff, and so on, and we give nature a chance to filter that naturally through the mechanisms that have existed for much longer than we've been here to deal with that. And that's, again, that's going to take some forethought, it's going to take some backbone, but it's something that I think needs to be done. And the last thing I would end with is, we're focused on the IRL and water quality in the IRL, but I would just remind us all that water quality issues across the country, but certainly across Florida, are paramount. And it's just not the IRL, it's the St. John's, it's the springs, it's the drawdown of the aquifer. It is a big problem, and it's only going to get solved by our representatives putting in place the right kind of ordinances and requirements to deal with it, because I think Vince is right on. We are doing everything we can within the scope of the plan to deal with the threats, but I share his concern. I'm not sure we're gaining on the problem. And so some of these things like limited impact development are the kinds of steps that we need to take to really get our arms around this problem. Thank you.
Anybody else?
Super quick.
ahead.
Laura Lee made a very good point yesterday in the workshop regarding how we value, either in the plan or just numerically, as we're removing or reducing the poundage of nutrients, we need to understand and somehow capture the added value of certain types of projects, leading to other indicators of success, like getting a sandy bottom and allowing seagrass regrowth through certain muck projects, dredging projects and things like that. So it's not just a narrow tunnel vision look at the math of nutrient removal. I think we need to somehow capture that, especially when we're proposing revisions of the plan in the future. That's all.
Todd?
I would just like to follow up a little bit on what Terry said, and this happens to be an area that I disagree with John Byron on. And I think we're doing a lot of good work. I think we have a lot of the right things here. But if through all of the science and all of the data that we identify another contributor or an ongoing issue or anything that is outside of the scope of our plan that would invalidate or in the end significantly reduce the impact that this plan has in the long term, then I think it is then whether it's specifically called out in our charter or not, we are remiss if we don't address it. And so if we identify things, whether it's low impact development or any other related matter that is an ongoing contributor of nitrogen to the lagoon that will limit the effectiveness of this for children and grandchildren, then shame on us. So if that means ordinances or legislation or whatever, then I think we ought to propose it. And whether that's in our charter or not, I don't think it's so far removed from what we're here about that it's not well within our purview to go ahead and address it.
Concur.
Thank you.
What are we allowed to say or do in regards to that, Virginia? Do we have any restrictions with what we propose to the county commission?
Sure. You're an advisory board, and I have seen other advisory boards, for example, Zoning Board of Adjustments. They saw a repeat of variance requests that concerned them, and they made a recommendation that the board consider an ordinance to address that concern. I think that would be within the purview of this advisory group as well. It doesn't hurt to ask. The worst they can say is no.
Okay. I think we should ask.
I think we need to extend the meeting for 15 minutes.
Do we?
I don't know, are there more comments?
I'm about 1 minute from adjourning.
Okay, I have a comment.
So do we need to extend?
The workshop yesterday, I'm not sure if everybody had a chance to see it. I thought it was a really good step forward in trying to merge utilities, but I might want to ask if Brandon or somebody could email to the whole committee the link to the county website where the video is. Sure. And that way, if you haven't seen it, please spend the time before our next meeting. And the only other thing I'll say is I hope we can get to the point where we bring in the municipalities who have wastewater treatment systems into this discussion. The discussion yesterday, I thought would have been benefited by having those guys there too. Yeah. The county commission oversees the whole county, but all those municipalities that operate wastewater systems are part of this decision-making process too. So we really need their input. And so I know that's not going to happen instantly, but down the line, we need that.
5 more seconds. I know, I'm glad I'm here. Can we have, like, as a homework, going off of what Todd was talking about, I think that's huge and very important. Can we have as a homework task item to kind of brainstorm on our own things that we can also do on outside of the fund management, but send that to Virginia for her to collect, and she can maybe let us know what some of the options are. Just procedurally, that might be helpful. Way forward.
I'm not clear on what you're asking.
We were talking about other things that we can do for, for the lagoon, planning, low impact development issues.
Okay.
other
Recommendations.
ordinances, other policies.
Things to advocate
right.
for.
Ask Virginia now. It sounds like we have, the ability to suggest things and advise it and bring it forward to the county commissioners, and if they
From
decide
my
to...
perspective, it's Virginia being aware that as these discussions come up,
Yeah.
that we note things that have come up, low-impact development comes up and then perhaps maybe a couple times a year, we say, okay, is there anything that has come out of all of our discussions and so maybe that's just an agenda periodically.
Right.
So.
I motion to extend the meeting by 2 more minutes. So we can finish this conversation. We're over.
Conversations are over. Are they over?
Yeah.
Yes.
The meeting is adjourned.
The opinions expressed by any member of the public during any period of public comment do not necessarily reflect the views or opinions of the Board of County Commissioners of Brevard County, Florida, Space Coast Government Television, or the program sponsor, and are solely those of the presenter. The Board of County Commissioners of Brevard County, Florida, Space Coast Government Television, and the program sponsor hereby expressly disclaim any and all responsibility or liability for any defamatory or slanderous statements expressed by any member of the public during any such period.